Well, we have a question here that says, Themba is planning a bicycle trip from Cape Town to Pretoria. The total distance covered during the trip will be 1,500 kilometers. He plans to travel 100 kilometers on the first day. For every following day, he plans to cover 94% of the distance he covered the previous day. Now, by reading the question, we understand that it is about a geometric sequence. Why? Because we have here, it is said here 94% of the distance covered the previous day. By that, the words of stand for multiply, okay? The words of in English stands for multiply in mathematics. So 94% of the, so every distance it covered the previous day, the next day is going to be times 94%. So by that we understand it involves a constant ratio. So this is a geometric sequence. Now, question 3.1 says, what distance will he cover on day 3 of the trip? Now, on the right here, question 3.1. 3.1. We're looking for Tn, okay? Actually, T3. And then, because this is a geometric sequence, Tn is given by a r to the n minus 1. So, okay, the first trip, the question says also that he plans to cover 100 kilometers on the first day. So T1 is the same thing. You know, T1 is equivalent, is just A. This is equal to 100 kilometers. Okay. And then the constant ratio here is 94%, which means 0.94. Now we can substitute the values in the formula. So it's going to be T3 will be A, which is 100. Okay, the first term, which is the first trip, and now R, the constant ratio is 0.94. Okay, to the power of n minus 1. We can sub in substitute 3 for n, so T3 will be all this to the power of n minus 1, so 3 minus 1. Now let us use a calculator to solve this. I'm going to use a calculator. Let's enter the values there, like at 100 there, open square bracket, 0.94, close bracket, and then to the power of 3 minus 1. Now, when we hit equal, we have this answer. Now, sometimes calculator writes the answers in fractional form. So now, in this situation, just press the button SD to get the decimal form of the answer. So we can say, therefore, T3 is just 88.36 kilometers. So that's T3. Okay. Now, the following question is question 3.2. The question says that on what day of the trip will Themba pass the halfway point? Now, we talk about okay, on what day? So I'm gonna write here question 3.1. I'm gonna write here question 3.1. 3.2, excuse me. 3.2. So we're looking for n here. And then the question says that halfway point. What is halfway points? Is just like, okay, I'm gonna write here halfway. Halfway will be halfway point will be equal to what? Okay, we do know that the total trip is like 1,500 kilometers. Now half of that will be 750. So I'm gonna write here 1,500 divided by 2. So halfway point will be when it covers 750 kilometers. But remember, this must be a cumulative distance, okay? Because it's gonna be the distance covered in the first day, the second day, until a certain day. n, the sum of all this distance must be equal to 750. So the sum of the distances Sn, the sum of the term in the sequence, in the geometric sequence, is given by A, open bracket, 1 minus r to the power of n, all over 1 minus r. I use this formula. I know there are two formulas. Sometimes you see it's written r to the power of n minus 1. I prefer this one only when r is in between. I prefer this one only when r is in between -1 and 1. Okay. So in this case, I'm gonna use that formula, and then this means that's 100. Okay. Open. I prefer to use square bracket now. Square bracket. 1 minus 0.94 to the power of n, okay, all over 1 minus 0.94. This must be equal to 750, halfway point. Now, I want to emphasize that over here, we cannot do 1 minus 94 and then take the answer to the power of n. We cannot do that. You cannot say this is 0.06 to the power of n. Okay, it must be treated separately because they are two separated terms. Now, this will be what? Okay, let me move my board this way, and then split it like this because of space. Okay, so now the denominator here, 1 minus 0.94. This denominator is just equal to 0.06. Okay, 1 minus 0.94 must be 0.06. So I'm gonna write over here, that's 100. Open square brackets. 1 minus 0.94 to the power of n, close brackets, all over 0.06. Okay, and that will be equal to that will be equal to 750. Okay, now you know, 750 like this has a denominator of 1. Okay, so what we can do is to solve this, we will just cross multiply. I'm going to take this numerator, okay, times by 1, and then take also 0.06 times by 750. Now this will be then 100. Okay, open square brackets, 1 minus 0.94 to the power of n equal to 0.06 times by 1. No, times by 750. Okay. Now here I times by 1, so I cross multiply the numerator, this numerator times by 1, and then this denominator times by 750. Now this will be equal to 100, open square bracket, 1 minus 0.94 to the power of n equal to 45, because 0.06 times 750 must be 45. We can check this. 0.06 times 750 equal to 45. And then to solve this, we can just so what we can do, I can divide both sides by 100, divide by 100 here, and then that will be 1 minus 0.94 to the power of n equal to 45 over 100. We can, okay, if you press this in the calculator, you will get 9 over 20. And then we can move the 1 over. That will be 0.94 to the power of n equal to 9 over 20 minus 1. And then this will be, okay, there's a negative sign there. If I move the 1 over, just take this one moved over. And then we get -1 there. Then we'll have like negative 0.94 to the power of n equal to 9 over 20 minus 1 is just equal to -11 over 20. So we we have negative, we can cross the negative signs like that, and then we have left with 0.94 to the n equal to 11/20. Now, what can we do in this situation? Okay, I'm gonna move my board this way. Okay, Ash. N will be equal to what? Okay, if I can put the logs, okay, both sides, I will have like, if I put log over here and then log over there, this will be 0.94 to the power of n equal to log of 11/20. Okay, 11/20. Now, according to log properties, the log property says that log of a to the power of n is equal to n log of a. Okay, so this simply means it's going to be like n times log of 0.94 equal to log of 11/20. And then that makes what? To get n, we can divide both sides. We have log of, so it's going to be log n will be equal to log of 11/20 over log of 0.94. Now that will give me the value of logs. So we can do log of okay, not this log. Use this log rather. So of 11/20. Okay, over log of 0.94, close bracket, and then when we hit equal, then we have like 9.661983. Now I can just stop by the second decimal place. By that it means we must look at the third decimal value, because the third decimal value in this case is lesser than 5. Okay, if this one there is less than 5, this third decimal value, and then we stop by 9.66. So n would be 9.66. So, but the day must be whole numbers. So we can say therefore n will be equal to, will be on the 10th day. Okay, on the 10th day, on day 10. Thank you. What does the following question says? Okay, n must be equal to 10. So the following question says, question 3.3. Timber must cover a certain percentage of the previous day distance to ensure that he will eventually reach Pretoria. Calculate all possible value or values of this percentage. Right. I feel like I need to read the question over again. It says timber must cover a certain percentage of the previous day's distance to ensure that he will eventually reach Pretoria. Calculate all possible value or values of this distance. Well, the fact that we had like R was equal to 94% here. Okay, 94% is equivalent to 0.94. And I said this one is in between -1 and 1. This tells us that this distance is actually this sequence, this series is converges because R is in between -1 and 1. Okay, so I will say, let me write here. We're looking for possible R. Okay, so question 3.4. We're looking for certain ratio. That's right. Okay. Now, S to the infinite, because this is the sum for convergence series, is equal to A over 1 minus R. So S to the infinite, we know this is S to the infinite will be equal to A, which is 100 over 1 minus R, 1 minus R. But now the sum Sn, okay, the total distance is equal to 1,500. It must be lesser than the value here. Okay, the total distance must be lesser than the sum to the infinite. So 1,500, or I can say 100 over 1 minus R must be more than 1,500, because this is the sum to the infinite. Okay, you must note that I'm going to write it here. S infinite is more than Sn. Okay, so we can solve this again by cross multiplication, because over here it has a denominator of 1. So this will be 1 minus R times 1,500 equal to 1, must not equal, but greater than, is greater than 100 times 1. And that makes 1,500 minus 1,500 R. I don't really need to expand this. We can divide both sides by 1,500 now. And then this will be 1 minus R will be greater than 100 over 1,500. Now let us simplify this, because we can cross the zeros and those zeros, so like 1 over 15. So this makes 1 minus R is greater than 1 over 15. I can move the 1 over, okay? If I move 1 over, we'll have like negative R will be greater than 1 over 15 minus 1. And then that makes negative R will be greater than negative 14 over 15. Okay, we can cross then these negative signs like that one more time. But now by doing that, at the moment that we simplify this, okay, the sign will change all around. Okay, yes, one thing. When we times here, okay, this will be positive times positive. Okay, the sign here would have been yes, I was saying the sign here would have been lesser than, because if the left hand side is more than the right hand side, okay, then at times something from the left hand side to the right hand side, the symbol here was supposed to change. So it's going to be lesser than. Over here also lesser than, and then there also lesser than, but now at the time that I cross the signs like this, be careful. This is not an equality, but this is an inequality. At the time that we cross the negative, we change the negative to positive, this the inequality must also reverse. So R will be greater than 14 over 15. Okay, and then 14 over 15 is 90 something percent. Let's check. 14 over 15 is equal to, we press SD like that, and then we times by 100, and then 100%, this is equal to 93%. So therefore R must be more than 93%. So must be more than 93.3%. The concentration. Thank you.